For this video, I'd like to talk about solving word problems with inequalities, or specifically using inequalities to solve problems. So let's start by just jumping into these word problems. Alonzo went to the market with $55 to buy eggs and sugar. He knows he needs a package of 12 eggs that cost $2.75. And after getting the eggs, he wants to buy as much sugar as he can with his remaining money. The sugar he likes comes in boxes that each cost $11.50. And we're going to use a variable S to represent the number of boxes of sugar that Alonzo buys. So S is just how many sugar boxes he buys. And we know that he can only spend $55. He doesn't have any more money than that. So let's say in general that the cost, we'll say the total cost, has to be less than or equal to $55 because he can't go more than that. And now let's work on this left-hand side. Well, what makes up the cost? So he has to buy a package of eggs. That's non-negotiable. The cost is going to be at least that $2.75, but then we're going to be adding to that because we have to buy sugar as well, or Alonzo has to buy sugar. So each box of sugar costs $11.50, and he's going to buy S boxes of it. So each box is $11.50, which means we will multiply that by the number of boxes. So if he buys 3 boxes, then you want to take 3 times $11.50. Though we want to leave it as a variable expression because we don't know yet how many he can buy. So we'll just leave it as S. So it's $2.75 for the eggs, and then plus $11.50 times S for the sugar. Since, like I said, if he bought 3, you would just plug in 3 for S, and then 3 times $11.50 would give you the cost for 3 boxes. So this cost has to be less than $55. So we can just write that out. That $2.75 plus this $11.50 times S has to be less than or equal to 55. So for question 1, which inequality describes the scenario? We just want to look for the one we came up with. The $2.75 plus $11.50s has to be less than or equal to $55. You could immediately eliminate these two because they are spending more money than they have. So they're saying the cost would be bigger than 55, so that wouldn't work. And this one wouldn't work because you're not paying $1 for each box of sugar. Because this one, notice, if you put in 5 for the number of boxes of sugar, it would just be $2.75 plus 5, which is not the cost of those 5 boxes of sugar. So now that we have the right inequality, let's try and solve it. We want to figure out the most boxes of sugar that we can actually afford, or that Alonzo can afford. So we just need to solve for S, essentially. So let me just use a darker color. We'll work right here. So 2.75 plus 11.5s less than or equal to 55. So we got to solve for S, so I'm going to subtract 2.75 on each side so that we get 11.5 times S less than or equal to 52.25. And now we do division. We divide each side by 11.5. And so we get S is less than or equal to, and we'll say about 4.54. So it's not exactly this. The decimal goes on a little bit more, but we'll just round it there. And so S has to be less than that or equal to that. So what this means is that if he buys 5 boxes of sugar, then his cost will be more than $55. But if he buys if he buys 4 boxes of sugar, his cost will be less than $55. So it has to be less than 4.54, but you can't buy a fraction of a box of sugar. You have to buy a whole box. So if it was less than or equal to 5 point something, then he could buy 5. But since it's less than or equal to 4 point something, and you have to buy a whole numbers amount, you got to go down. And so 4 is the most that he could actually buy. So 4 is the answer to that question. But you can double check your work here. Just take your 1150, multiply it by 4, and let's see what you'd get. You'd get 23 if you double it, so doubling it twice gives you 46. And then plus the 2.75, we want to add to that. And so that gets you to 48.75. But you can see if you bought another box of sugar, if you added another 11.50 to that would put you way past 55. So when you checked it, it did actually make sense that 4 was the most that he could afford. So let's move on. We're going to do 3 more of these. So for this one, Benjamin decides to treat himself to breakfast at his favorite restaurant. He orders chocolate milk that costs $3.25. Then he wants to buy as many pancakes as he can, but he wants his bill to be at most $30 before tax. And the restaurant only sells pancakes and stacks of 4 pancakes for $5.50. So S is going to represent the number of stacks of pancakes. So with this question, you want to be a little bit careful because this information here about how the stacks are in 4 pancakes, that's actually not relevant information for this first scenario. Now for number 2, it will come into play. But for now, our variable S represents the number of stacks, and each stack is $5.50. So for this one, we'll say his total cost has to be at most $30. So it has to be less than or equal to 30. And now we just have to figure out what the cost is. So in this case, he buys a chocolate milk. So that's a fixed expense, $3.25. And then he's going to buy stacks of pancakes. And so each stack is $5.50. And we'll say S is the number of stacks. So we're going to multiply those. So you get $5.50 times by S. And you want to make sense of that. Because if you buy, let's say, 3 stacks, then you would put in 3 here. And 5.5 times 3 would give you the cost of those 3 stacks. So this does make sense that you should multiply these together. So let's just combine these ideas now so that we get our inequality. So it's the chocolate milk, $3.25, plus the pancakes, 5.5 times S, has to be less than or equal to $30. So we look for that one, and like the last one, we can eliminate the ones that were more than 30, because then he would be spending more than he wants. And this one doesn't make sense because S is not multiplied by the price per stack, so that one doesn't work. And you can see this letter C is what we came up with. The cost of the chocolate milk plus the cost of each stack of pancakes has to be less than or equal to $30. So what's the largest number of pancakes that he can afford? Well, the first step is to solve for S. We got to figure out how many stacks he can actually buy with his remaining money. And then from there, we can just multiply it by 4 to get the total number of pancakes. So let's subtract 3 1/4 on each side to get the S term by itself. So these cancel. You get 5.5 times S is less than or equal to, this would be 26.75. And now dividing each side by 5.5, we can figure out what S is. So what you find is that S would be less than or equal to 4.863, where the 63 is going to repeat. And just like the last problem, you can only buy a whole number amount of stacks. You can't buy a fraction of a stack. So we're not going to be able to buy 4.863 amount of stacks. So you can either buy 5 stacks or you can buy 4 stacks. And 5 would be too many because the number of stacks has to be less than this 4.863 repeating. And so 5 would not satisfy that. So 5 stacks, and you can check the math, 5 times 5.5 plus this 3 1/4 would put you above 30. So we have to buy 4. 4 is the most amount of stacks. So 4 stacks, and then times by 4 pancakes, we can say per stack. And so stacks cancel out, and you just get pancakes. And 4 times 4 is 16. So 16 pancakes is the most that Benjamin can afford. Now, you can check this just like the last one. Just do your 3 1/4 plus 4 times 5.5. Since we're buying 4 stacks, and each stack is 5.50. So 5.5 times 4. Well, if we double that, we get 11, and the doubled again gives us 22. And then plus our 3.25. So we can add that on. You get 25.25. And another stack is $5.50. So if you add $5 to this, you're going to go above 30. So that's why 5 can't work, and 4 is the most amount of stacks that he can afford. And since each stack has 4 pancakes, you just multiply by 4 to get your 16 pancakes for the most that he can actually afford.